Hi there. For our lesson today, we are talking about Chapter 4, Application of Differentiation, Lesson 2, Second Derivative Test, Part A, Concavity and Point of Inflection. In our lesson for today, I'll try to explain what is the point of inflection and how we know that the function at the interval is concavity, and explain what is the relation between the function and the first derivative and the second derivative. Let us start our lesson. Convex. The graph of f is convex on interval AB if, open interval AB if f double prime of x is less than 0. That means the second derivative must be negative. It means that the graph of the f double prime under the x-axis, the graph of the f double prime, that means the graph of the second derivative is under the x-axis, and f prime is decreasing because f double prime is less than 0. That means f prime, that means the first derivative is decreasing. As you can see here at this graph, this is the graph of the function, the black one, and the graph of the first derivative f prime of x is decreasing, as you can see here. It is decreasing, and the graph of the second derivative is under the x-axis, Concave. The graph of f is concave on the open interval AB if f double prime x bigger than 0. That means the second derivative must be positive. It means that the graph of double prime f is over x-axis, and the first derivative is increasing, and the graph of the, as you can see here, this is the graph of the function, and this one is the graph of the second derivative, which is over x-axis, and the graph of the first derivative is increasing. Point of inflection. C f of c is inflection point of the graph of a function if f double prime, that means the second derivative, is equal to 0 or it is not exist or not defined it, and f prime has a local maximum or a local minimum, and the inflection point change the sign of the second derivative from negative to the positive, or from positive to the negative, or from convex to the concave, or from concave to the convex. From this notation, or from this definition, we can say that if the first derivative have a maximum, local maximum, or a local minimum, that means this point it be a inflection point. Step of finding the concave and convex interval and inflection points. First of all, find the first derivative and the second derivative. The second step, solve the equation f double prime x is equal to 0. That means make the second derivative equal to 0 and solve the equation and find the value of x. Third step, draw the value of x on the number line or draw a table of the values. The x values divided the number line into few parts. We take the number from each part and substitute it into the f double prime. If after substituting the value of f double prime is bigger than 0, that means it is an concave interval. And if the value of double prime of x is less than 0, then it is convex. Let us take the first example. Find the interval on which the graph of the function f of x is equal 1 over 16 x to the power 4 minus 3 over 2x to the power 2 is concave and those on which is convex. First of all, we must know what is the domain of this function. As you know, this is the polynomial function, so its domain is all real number. F prime of x, first of all, find the first derivative. F prime of x is equal 4 times 1 over 16 is 1 over 4 x to the power 3. 3 over 2 times 2 is 3x. And now take the second derivative. The second derivative is 3 times 1 over 4 is 3 over 4 x to the power 2, 3. And now make the second derivative equal to 0. F double prime of x is equal 0. So 3 over 4 x squared minus 3 is equal to 0. Multiply both sides by inverse of this 3 over 4, make it 4 over 3. So it become cancelling 4 with 4 and 3 with 3, and here 3 with 3. The result be x squared minus 4. And take the 4 from left side to right side, become x squared equal to 4. Take the square root of the function of the equation, so x is equal plus or minus 2. That means we have 2 points. Maybe they are be a inflection point. Draw the number line. Our domain is from minus infinity to the positive infinity, and we have 2 points, minus 2 and minus 2, and the value of the second derivative at minus 2 is 0, at 2 is 0, 2. And now we must take here from minus infinity to minus 2 a number. Let us take minus 3. Minus 3 substituted at the second derivative. Minus 3 squared is 9. 9 times 3 is 27. 27 over 4 is bigger than minus 3. That means it is positive. It has become 3.75. That means it is positive. That means because it is positive, so the function is concave. The function is concave. The second derivative is positive, so the function is concave. And now let us take between minus 2 and 2 a point, let be 0. Replace it as the second derivative. So f double prime of 0 is 3 over 4. 0 squared minus 3 is equal minus 3. It is less than 0. That means it is minus. So it is convex. And now let us take a number bigger than 2. let be 3 and replace it at the second derivative, it become the second double prime of 3 is equal 3 over 4. 3 square minus 3 is equal 3.75. Is bigger than 0. That means it is positive, so it is a concave interval. That means the function is concave interval, and concave interval is from minus infinity to minus 2, union from 2 to the positive infinity, and convex interval is minus 2, 2. And the 2 point minus 2, minus 5, and 2 minus 5 are the inflection points, as you can see at the graph of this function. You have 2 inflection point, and the function is concave from minus infinity to the minus 2, and from 2 to the positive infinity is concave, and it is convex on the minus 2, 2. Let us take the second example. Find the interval on which the graph of the function f of x is equal x to the power 4 minus 4x squared plus 1 is concave, and those on which it is convex. The domain of this function is all real number. Take the first derivative. F prime of x is equal 4x cubed minus 8x, and the second derivative is 12x squared minus 8. Make the second derivative is equal to 0, so 12x squared minus 8 is equal to 0. Dividing by 4, so 3x squared minus 2 is equal to 0, and the x squared is become 2 over 3 by taking the square root of both sides. X equal plus or minus square root of 2 over 3. And now draw the number line x from minus infinity to the positive infinity, and we have 2 value of x minus square root of 2 over 3 and plus square root of 2 over 3. The derivative at these 2 points, the second derivative of these 2 points are 0, and the value of fx is minus 11 over 9 and minus 11 over 9. By replacing the value of x from to the function of from the function, and find the value of fx. And now take from minus infinity to minus 2 over 3. Minus 2, replace it at the function, the second derivative. F double prime minus 2 is equal to 12 times minus 2 square minus 4 is equal for t bigger than 0. That means it is positive and it is a concave interval. And we take 0 between minus and positive. F prime of 0, f double prime of 0 is equal 12 times 0 square minus 8 is equal minus 8, less than 0. That means it is a convex. And take here 2 and replace it. F double prime of 3, it is 2. 12 minus 2 square minus 8 is 40, bigger than 0. That means it is a concave interval. That means concave interval is from minus infinity to the minus square root of 2 over 3, and from square root of 2 over 3 to the positive infinity. And convex interval is from minus square root of 2 over 3 square root of 2 over 3. And we have 2 inflection points. The first one is minus square root 2 over 3 minus 11 over 9, and the second one square root of 2 over 3 with minus 11 over 9. Identify the points of inflection and discuss the concavity of the graph of the function f of x is equal to x to the power 4 minus 2x cubed. If we have the graph of this function, as you can see at this graph, here the function is concave, and here is going to be convex, and here is become to the concave too. That means we have two reflection point, one of them at the 0 0 and the second one from 1 minus 1. This is the the reflection points, and at this interval from here to the 0 it is concave, and from 1 to the infinity is concave, but at the 0 to 1 is a convex interval. And now if we want to be sure, take the second derivative. F prime of x is equal 4x cubed minus 6x squared by taking the derivative of this function, and take the second derivative. 3 times 4 is 12x squared minus 2 times 6 is 12x, and make the second derivative f double prime of x is equal 0. And now take 12x squared minus 12x is equal to 0. You have a common factor 12x, take it out, so 12x become x minus 1 is equal to 0. From 12x is equal to 0, x is equal to 0. From x minus 1 is equal to 0, x is equal to 1. These 2 points are an inflection point. And now to make to know what's the interval of concave or convex, draw a number line, and we have 2.1 and 0, and f double prime at these 2 points are 0. And now take a number from minus infinity to 0, let be minus 1, and replace it at the second derivative. If we take the minus 1, so f minus 12 time minus 2 minus time minus is positive. That means this interval is concave. And take from 0 and 1/2, if you know it's become 6, and here minus half, minus half times 6 is minus 3. That means it is a these 2 points are concave, and here we have convex, and that means the concave interval is minus infinity to 0 and 1 to the positive infinity, and convex interval are from 0 to 1. The inflection points are 0 0 and 1 minus. Find the open interval on which f of x is equal 1 over x squared is concave. If we draw the graph of this function, you can see this is be like this. The function is concave from minus infinity to 0 and from 0 to the positive infinity. That means this function is concave at its domain. If we want to find this, first of all find the first derivative. F prime of x is equal minus 2 over x cubed. If we draw the graph of the function of the derivative, it's be like this, and this function is increasing from minus infinity to the 0 and from 0 to the positive infinity. And f double prime of x is become 6 over x to the power 4, and because 6 is positive and x to the power 4 is positive, positive over positive is positive number, so it is bigger than 0, as you can see. at the graph of this function, the second derivative graph is over x-axis. That means it is a positive. That means the f is concave on the interval minus infinity to 0 and from 0 to the positive infinity. That means the convex interval does not exist. But if you see that we have two parts of this interval, one of them at A and the second one is B, that means A and B are true. So the C is a correct choosing. And now find the open interval on which f of x is equal x plus cosine x on the interval 0 to pi is concave. The domain of this function is from 0 to the 2 pi, and the first derivative is the derivative of x is 1, the derivative of cosine is minus sine, and the second derivative of 1 is 0, and minus the derivative of sine x is cosine x. Make the second derivative is equal to 0, so cosine x is equal to 0. That means x is pi over 2 or x is 3 pi over 2. These 2 points are inflection point. And now draw the table of value from 0 to the 2 pi, and we have two value, pi over 2 and 3 pi over 2, and the value of double prime at these 2 points are 0, and the value of fx from pi over 2 is pi over 2, and from 3 pi over 2 is 3 pi over 2. And we take 180 in this interval and replace it at the second derivative. And now f double prime of 118 or pi is equal minus cosine 180. It's become minus 1, it is 1, it is positive. That means in this interval the function is concave. At these two intervals it is convex. That means the concave interval is from pi over 2 to the 3 pi over 2. And inflection points are pi over 2 pi over 2 or 3 pi over 2 3 pi over 2. Here we came of the end of the lesson. Please do not forget to subscribe the page to get every new video, and write your comment if you have any, and push the like button. Thank you for that, and goodbye.